I make this video for my class EL6303, and here's the second question in homework 2. First, we're going to solve the first problem. We need to find a so that make this function is a valid density. If it's a valid density, first we should know that this it would equals 1. So because of it, we need to take things into this equation. So we could get 0 to 1. Obviously, this part equals so from this equation we could know that a equals 1. Next we move to the second problem. We need to sketch this function. From the first question we have already get the answer that a equals 1. We need to take a equals 1 into this function. So it is we could easily sketch two parts. The first is this part. The second is this part. Here is otherwise. So this part is 0, here's 1, and this part should be this. The most important is this one, because it's really hard for us to draw it now, so we need to figure out this function, and we're assuming that gx equals in the range from 0 to 1. So we could get the basic property of this function, since in the range from 0 to 1, it is positive. So because of this, we could know that this is an increasing function. Obviously, it is positive as well, so it is convex. This function is convex. We need to talk about it again. When x equals 0, we could know that it will be when x equals 1, it will be here. And take this two property in. According to this two property, we could draw this part. But actually in this range, x could not be 0 or 1. So they should be empty. This is the figure of fx, and in the third problem, we need to write fx in one line by using step function. So back to this again. Obviously, we have already know that a equals 1, so we could write it directly. It should be like this. And move to the first problem. We need to get a distribution function. Because actually the density one can be three parts. The first part is the second part is this. Because of this, it could be right into three parts. So obviously we know that if x is smaller than 0, it would be 0. And if x equals 0, it would be this. And if x is in the range from 0 to 1, it could be like this. Sorry, this should be 2. So it will be this. A plus so here. If x equals 0, they are same. They are the same. So we could combine these two parts together. It will be right into this way. Sorry, it should be x. And in this part, 0. Oh, sorry, this one. Of course, when x is, it should be 1. So here is expression of fx, the distribution function. And the last one, we should sketch the distribution function fx. we have already get the expression of it, so we just to sketch it according to the expression. I'm gonna write the expression down here. It would be this. Oh, it should be minus. Yeah, it should be minus. Minus 1, x smaller than 0. Here. So we're gonna draw it. Here is fx. Here is x. Here is so when x is smaller than 0, it's 0. When x is in the range from 0 to 1, I'm gonna draw this part. Of course, it's really hard to distinguish as well, so I'm gonna use the same method to analyze this part. We're assuming that gx equals obviously the x should between this part, and it could be obviously it is positive, so it is an increasing function. In the range from 0 to 1. This part so it is convex. When x equals 0, it would be, so it would start from here, and when x is 1, it is 1. And according to the two properties, we could draw it into this way. Of course, in this part, in this section, the x could not get 1. That could not be 1, so this should be empty. But later we skip to the next section. When x is bigger than 1 or equals 1, it would be 1, so I'm gonna continue to draw that. So this empty part would be filled. So here is the figure of the distribution function fx. These are the solution for my second problem.